a UDL or a point load, both extremely common and are likely to come up in the interview. We recommend that you learn the moment, shear, and deflection equations off by heart as they are beneficial and come up almost every day. The deflection equation is probably most using steel beam design. Cantilever structures, knowing these two equations is essential, which are commonly found in balcony designs. This is the following equation. A quick way to determine reinforcement required in a concrete section without going through the entire design, which you can do later. There will be a lot of times when you're going to be creating concrete frame models or doing quick checks. You will have some bending moments from the analysis and need a rough idea to find what kind of reinforcement you need in the section, or if the depth of section is adequate. You only have three variables: ultimate moment from the analysis, steel strength, which it is just a constant. The effective depth of reinforcement you can work out from the compressive face of concrete to the center of reinforcement. It will be straightforward with this equation to determine what reinforcement you need and if the depth will be adequate. The next equation is the elastic modulus used for calculating moment resistance. We commonly use this when determining bending resistance of a flat plate section such as an I-beam with a top plate on. You need to check that plate for a bending moment. For a rectangular section, B is the width and D is the depth. Take care not to confuse the elastic section modulus with the modulus of elasticity. There is no connection. The first is a geometric property based on the shape and dimensions of a section. The second is a material stiffness property. The next equation is the second moment of area, or sometimes also known as the moment of inertia. While not commonly used on its own, it is an equation that you should understand because it is similar to the elastic modulus, and it's beneficial for determining the second moment of area about the neutral axis in plate girders by using parallel axis theorem. The following equation is a stress equation: moment over I for the second moment of area, which equals to S stress over Y for the depth. You drive this. This equation requires you to know the second moment of area or the moment of inertia. Very useful in foundation design when you have both point load and the moment. It's helpful to work out the net stress on the ground and check they don't have any uplift or tension. The typical use case would be for retaining wall design, but you need to design the footing to ensure you're not overstressing the ground due to retaining pressures. Many equations need to be used as a structural engineer, but there aren't very many you need to learn as long as you know where to find them. For instance, Fiona Cobb's Structural Engineer's Pocketbook. As long as you know where to find out in the code, you know that's enough. Knowing these equations off the top of your head will be extremely handy and make your work life considerably easier.